Why is the Earth's core cooling? Imagine standing on a giant stove that's been cooling down for billions of years. Sounds surreal, right? Yet this is exactly what's happening beneath our feet as Earth's core gradually loses heat. Welcome to Zain Facts Channel, where we unravel the mysteries of our planet and beyond. The Earth's core formed around 4.5 billion years ago from the cosmic dust and gas that also birthed our solar system. Initially, the Earth was a molten mass, but over time, the denser materials sank to form the core, while lighter materials floated to the surface, creating the crust and mantle. This differentiation process trapped a significant amount of heat in the core. However, the Earth has been cooling ever since its formation. Heat from the core is transferred to the mantle and then to the surface through various processes like conduction and mantle convection. The primary sources of this heat are residual heat from the planet's formation and the decay of radioactive elements such as uranium, thorium, and potassium within the mantle. Interesting fact, the temperature at the Earth's core is comparable to the surface of the Sun, reaching up to 9,932 degrees Fahrenheit, or 5,500 degrees Celsius. Another interesting fact, the core's heat is crucial for maintaining the geodynamo effect, which generates Earth's magnetic field and protects us from harmful solar and cosmic radiation. Recent studies have revealed that the Earth's core might be cooling faster than previously thought. Researchers at ETH Zurich discovered that bridgmanite, a mineral found at the core mantle boundary, conducts heat more efficiently than earlier estimates. This higher thermal conductivity implies that the core's heat is being transferred to the mantle at an accelerated rate. Interesting fact, bridgmanite, named after the Nobel laureate Percy Bridgman, is the most abundant mineral in the Earth, though it's only found deep within the planet. Another interesting fact, as bridgmanite cools, it transforms into a mineral called post-perovskite, which conducts heat even more efficiently, potentially speeding up the core's cooling process. The cooling of the Earth's core has significant implications for our planet's geological and magnetic activities. One major consequence could be the eventual cessation of plate tectonics. The mantle's heat-driven convection currents are responsible for the movement of tectonic plates, leading to phenomena like earthquakes, volcanic eruptions, and mountain formation. As the core cools, these convection currents could slow down and eventually stop, altering the Earth's surface dynamics dramatically. Interesting fact, plate tectonics play a crucial role in the carbon cycle, regulating Earth's climate over geological timescales. Another interesting fact, the cessation of plate tectonics could result in a more stable but geologically dead planet similar to Mars or Mercury, which have little to no tectonic activity. While the accelerated cooling of the Earth's core might sound alarming, it's essential to understand the timescales involved. Scientists estimate that it could take billions of years for the core to cool significantly. In fact, the Sun is expected to expand into a red giant and potentially engulf the Earth long before the core completely solidifies. Interesting fact, the Earth's core has been cooling at a rate of about 100 degrees Celsius per billion years since its formation. And here's another intriguing bit. The Sun will become a red giant in approximately 5 billion years, expanding so much that it could swallow the inner planets, including Earth. Segment 5. The core's composition and heat sources. The Earth's core is primarily composed of iron and nickel, with traces of lighter elements such as sulfur and oxygen. The outer core is in a liquid state, while the inner core remains solid due to the immense pressure at the Earth's center. The heat within the core comes from three main sources: residual heat from the planet's formation, the decay of radioactive isotopes, and heat released from the crystallization of the inner core. This crystallization process releases latent heat, contributing to the overall heat budget of the core. Interesting fact 9. The solid inner core grows by about 1 millimeter per year as the Earth cools and the outer core continues to crystallize. Interesting fact 10. The movement of the liquid outer core generates electric currents, which in turn produce Earth's magnetic field, a phenomenon known as the geodynamo effect. Segment 6. The role of magnetic field. The magnetic field generated by the core is crucial for life on Earth. It shields the planet from harmful solar and cosmic radiation, preventing the solar wind from stripping away the atmosphere. This protective magnetic field is responsible for phenomena like the auroras and helps in navigation for many species, including humans. Interesting fact 11. Without the magnetic field, Earth would be bombarded by solar wind, leading to significant atmospheric loss and increased radiation exposure. Interesting fact 12. Mars, with its weak magnetic field, has lost most of its atmosphere, making it a cold and barren planet. Segment 7. Long-term implications and human impact. In the long term, the cooling of the Earth's core could lead to a decrease in volcanic activity and plate tectonics, which would impact the planet's surface and climate. However, this process is incredibly slow, occurring over billions of years. In the short term, human activities such as mining and drilling do not significantly affect the core's temperature. However, understanding the cooling process helps scientists predict future changes in the Earth's geodynamics and magnetic field. Interesting fact 13. Human-induced climate change occurs on a much faster timescale than the natural cooling of the Earth's core. Interesting fact 14. Studying the Earth's core helps scientists understand the formation and evolution of other rocky planets in our solar system and beyond. So, while the Earth's core is indeed cooling, it's a process that will unfold over immense timescales, likely outlasting humanity itself. The intricate dance of heat and minerals deep within our planet continues to shape our world in profound ways. Thank you for joining us on this deep dive into Earth's core. If you enjoyed this video and want to learn more fascinating facts about our planet and beyond, make sure to like, subscribe, and hit the notification bell. Share your thoughts in the comments below. What other mysteries of the Earth would you like us to explore next? This is Zain from Zain Facts Channel signing off. Stay curious and keep exploring.